Yes.
No, we're all set. Got a mic. Let's start.
All good. Good evening, everyone. Welcome to our session. So today, India is not just a consumer of technology, but a primary architect of the global AI hardware stack. Without wasting any more time, I'd like to invite Additional Secretary Shri Amitesh Sinha ji, who's also the CEO of the India Semiconductor Mission, to start with his policy keynote on how the India Semiconductor Mission is fueling India's localized compute roadmap, followed by a panel discussion of eminent Indian builders who are building in the space of silicon, hardware, and compute. Over to you, sir.
Thank you. I will start with my dignitaries on the panel and dear members who are here today. Actually, we all know the journey, and we have seen that how Semiconductor India Mission is focusing on three particular aspects. One is design, second is manufacturing, and third is packaging. And in that process, the focus on design was basically on the startups in India Semiconductor Mission 1.0. You want to say something? Or not? Okay. So in design segment, we were supporting startups and MSMEs, and there was a very good traction, and we approved 24 such projects. They are progressing very well. Out of 24, 14 has already got VC funding, and now they are entering into next leg of journey. In manufacturing, we have already approved 10 projects, one fab, one silicon fab, one silicon carbide fab, and 8 packaging units. And then in ISM 2.0, because ISM 1.0 is over now, you may see a couple of announcements very soon, but it is over for new applications. And in ISM 2.0, we are going to focus on the complete ecosystem. So complete ecosystem means the earlier verticals will continue, like design, manufacturing, and packaging. On design side, we will increase our investment to a very great extent, and when policy will come, you will able to see that. In manufacturing and packaging, incentives will continue. And now we will add new verticals of R&D, which is very, very important for cutting edge technologies in all verticals, whether it is advanced technology nodes, or it is silicon photonics, or it is OLED technology for display, or it is any kind of similar technologies. Then we will also focus on equipment, which is very, very important for semiconductor manufacturing. So equipment R&D, equipment manufacturing, equipment components sourcing, all those things will focus. And then all kind of chemical, gases, and materials. These will be the focus area. And then a big focus on scaling. That is very, very important. So whatever efforts today we are doing, it is all earlier efforts, apart from some new initiative that we had taken in the form of curriculum revision and all that. But going forward, you will see that a national push for semiconductor skilling in all verticals, design, manufacturing, packaging, focusing on equipment needs, chemical gases needs, all those things will be covered in the new skilling techniques that will follow. Friends, this is a time where we need lot of investment from outside, including in design segment also. Today we are here to discuss VC funding also, as well as how the complete AI stack we are building. So when we talk about AI stack, the basic fundamental building blocks are semiconductor chips. In that we are also working, you know about the CDEC. So we are our own journey, and lot of high power computing machines we are now generating. Very soon you will see that the computing power of those machines will increase tremendously. We have developed certain capabilities like the board, the entire body, the cooling system, interconnect of high power computing that we have developed. CPU and GPUs now we are taking from outside, but that journey is there, and we will also reach out to a level when we own self-develop those chips also. On that, there are various different layers, and we are very strong in software. This is the AI is our moment. Since we are strong in software, we can develop a lot of good fundamental large language models also, application specific model also. In this AI summit, you have seen how companies are showcasing the new startup companies. They are showcasing their talent, in very less time, understanding the challenge, they have developed their system, but very soon it will be a very robust and very good system, and on many parameters, as Honorable Minister was telling, they are surpassing the available large language models today in the world. So I'll end here so that further we will discuss during the panel discussion. Thank you.
Thank you. See, this works. Can you get that? Thank you, Amitesh. Hi, everyone. I'm Rajan Anandan. That's actually my AI avatar because he has his name next to him. I've always wanted to be like Sashwat. So, firstly, welcome everyone. I think even 2 months ago, if somebody had told me there'll be a semiconductor panel at the AI summit at what time is it now? Like 5:30 p.m. And the room's going to be full, I would have said, man, that's going to be a bit of a stretch. In fact, when we suggested this panel, Amitesh, I told the team, please make sure at least there are 15 people in the room. And I said, ideal would be like 10 of them actually startup founders we could invest in. So firstly, thank you for coming and thank you for your interest. Let me get a quick, maybe show of hands. How many of you are building semi-startups? Anybody in the, I know, by the way, we have 3 semiconductor startups. I know the 3 of you obviously are I wasn't asking about you guys. Anybody in the room? How many are from large semiconductor companies? Okay, there's quite a few. Okay, good. Everybody else is, I guess, keen to learn, which is terrific. So look, the focus of our panel is we're going to focus on what does it take for India to become a global leader in semiconductors. Okay, I'll give you 3 interesting data points of why India can do pretty much whatever she decides to do. 2015, India was not in the top 100 countries when it came to digital payments. 2025, we were 60% of all global real-time payments in the world. Right? Today, there's no question in the world who leads the world in terms of digital payments. 2015, you probably know this, Amitesh, India had 2 space tech startups. Today, we have over 300 space tech startups, right? If you actually had asked us even a year ago, would an Indian model company be SOTA on voice in Indic languages? We'd have said that's a bit hard because you have Google and 11 Labs and all these companies. But as of like about 3 weeks ago, right, Sarvam basically became SOTA, state of the art, in both speech to text and text to voice. So, and this week basically India enters the model race, right, which we have 12 companies basically launching models. Obviously, there are, call it 1 billion to about 100 billion parameter models. They're not trillion parameter models yet. So I think, look, basically we can pretty much set ourselves to. And I want to start by thanking you, Amitesh, and the government of India and the India Semiconductor Mission for, I think, embarking on the mission. I think if you had asked me even like, I remember seeing Chandra like 18, whatever it was, like 2 years ago, when he had when they announced the fabs. And I said, are you really serious? And he said, look, you're getting an invite. Show up. When the fab opens. So the fact that we can actually build semiconductor fabs in India, that we have a design ecosystem and innovation ecosystem, I think is fantastic. So what we're going to do is, let me introduce very quickly our panelists. We have Dimant, who's the founder of a company called Agrani. Agrani basically is going to build GPUs. Yeah, you heard me right. They're going to build GPUs ground up. He's going to talk about that. It comes from I'm going to have each of them talk a little bit about their companies so that they can articulate in their own terms. Preetham is the co-founder of a company called C2I. C2I is basically making chips for power. Comes from Texas Instruments. Basically took the top 15 people out of TI in India who are building power chips. That's their company. They added another 45 people building power chips in every other company, for all the other players, and that's pretty much 60-person team that they have. They're going to have a tape out in April. Then we have Naveen. Naveen is from Marvell, leads Marvell's business in India. As you guys know, Marvell's $70 billion. Naveen, by the way, we only need about 5 $70 billion market cap semiconductor companies. And I think Amitesh can finally go to Honorable Prime Minister and say, I think we've done it now. And then finally, we have Shashwat. Shashwat is the co-founder of a company called Mindgrove. It was actually the first semiconductor investment that we made as a firm. We're Peak 15. And they're actually building SoCs, low-power SoCs, starting for the Indian market, chips that go into things like smartphones, energy meters, things like that. So we have 3 startup founders. We have the head of a global company that has been very, very seriously committed to India. And we're going to focus the next, call it 40. Actually, I'll ask questions for about 20 minutes, and then I'm going to open it up for you all. We're going to focus on this central question of what does it take for us to build global leadership, right? Because what we know is when we set our minds to it, takes between 10 and 15 years. Now, of course, lots of things need to come into place. Somebody just pointed out the world's most valuable company today is Semiconductor company. Insane, right? Like, that's like really insane. So, Amitesh, I'll start with you. Look, ISM 1.0, very successful. ISM 2.0, lots of excitement. If you just take this simple objective and say, look, in 10 years, we want to be a global leader, period. Is ISM 2.0 enough? Or if you had a free hand, i.e. allocate as much resources as you want, get ever, you wave your magic wand, what would it take?
So I'll only quote Honorable Prime Minister. He has very clearly said that this journey is for next 20-25 years, for the time being. It may continue forever also. So we'll see ISM 1.0 is about to over. ISM 2 very seamlessly it will come in next couple of months, and after that we may see ISM 3.0, 4.0, all like that, because this is not a kind of race, 100-meter race. It's a kind of marathon, and wherever semiconductor industry is completely set up, those countries have taken 20, 30, 40, 50, 60 years time to come to reach to this level, and nothing happens here in a day. So the
Can
first
something happen in a decade though?
Yes, obviously.
So like if you said, look, I know 30 years is better, 30 years gives us more time, but if we genuinely said, look, in a decade from now, 2036, India AI Summit is happening, we'll have 3.5 million people showing up at Bharat Mandapam, because hopefully it'll be like 10 times larger. I actually think that'll happen, by the way. I think every year this number is going to keep going up. Eventually we'll have to have many floors. So what would it take? And you can be honest, there's no media in the room, right? Is there?
In front of media,
a few media.
No
by the way, just don't write any of this, okay? Just don't write any of it. I mean, whatever you don't want them to write. So, what would it take?
So actually, from my side, there is no restriction. You can write anything.
Oh, there you go. Perfect. You're like Vinod Khosla. Vinod was in the other room just now. He said the same thing. You write whatever you want.
So, by 2030, we have 10 projects right now. All of them will be fully functional and commissioned.
So we'll have 10 fabs.
Not 10 fabs. We have approved one fab, silicon fab, one silicon carbide fab, and 8 packaging units. All of these 10 will start commercial production from this year, and they will attain full capacity by the end of 2028, 2029, and 2030. In the meantime, we will approve in ISM 2.0 many such projects, and some of them will again come because the period of setting up facility varies from 2 years to 5 years. So some of them will also come. So this 10 can become 15 or 17 or 18. But this time our focus is to create a fabulous company. So now the company sitting here, the
we have 3 candidates.
3 candidates. They are very, very promising, and we want to see them as a $1 billion fabulous company.
I don't think bigger, no.
No.
NVIDIA is like 5 trillion.
I have a timeline.
Don't stop at $1 billion, okay?
So I'm saying that.
Yeah, what is this? There 5 trillion, we're going to be 1 billion. You guys don't stop at 1 billion.
So he has given me a timeline. So I'm coming with that thing. In first phase, when ISM 2.0 will over, 3.0 will start. By that time, these companies, 24 companies, and the promising one which are also coming now, you will see some of the fabulous 1 billion company. And after that, we want to see them as a Broadcom, Qualcomm, NVIDIA, and all those kind of companies. So I'm setting this timeline. I'm very hopeful. We are working very meticulously to see that all piece of puzzle is in place, so that anybody can build up their solutions, whether it is design company or manufacturing company or packaging company or equipment company or any kind of new technologies that can prosper in this country.
Terrific. Thank you. And again, by the way, thank you so much on behalf of, I think, the entire ecosystem for the amazing work that the India Semiconductor Mission is doing. But I do think, by the way, these 3 will soon be, but just get there quickly, okay? Become a $1 billion company. Okay, Deeman, let's start with you. So, maybe you can start with a little bit, where's this even ambition coming from?
Yeah.
By the way, this is the level of ambition in the Indian startup ecosystem today, okay? This team has basically said we're going to build GPUs, period. That's it. We're going to build, we're going to compete with the absolute best in the world. So talk a little bit about whatever you can share. I know there's a lot you can't share.
Right.
Maybe your background, your team's background, just 30 seconds.
Yeah.
And then what are you guys trying to do, and why should we believe?
Yeah.
Because you're soon going to come to him, no, and ask for some big thing, no, from ISM. He's coming to you. He might have come to you already. So why should he believe that this team from India is going to build a GPU?
Well, actually, building a GPU is second nature for us, Rajan. We have been doing it for 30 years, right? So we have been doing it in hardware, in software, at Intel, at AMD, and IBM. So we just have to go replicate it.
Actually, that's a good point. You've just been building it. Now you're going to build it for yourself.
Yes.
And you're going to build it for India.
Yes, absolutely. So it's second nature for us. I don't worry about our ability to build a world-class GPU hardware-wise or software-wise. There are other things we can talk about that I worry about. But yeah, so our background is, you can see, gray hair, no hair.
But you still have black hair.
Black
you know,
hair,
I mean,
yeah, whatever. 25 years in the industry, founding team with 150 years of experience in these, MNCs. Built multiple generations of data center CPUs, GPUs. Our software leader is a 30-year IBM veteran, one of the most prolific open source contributors in the country. So one of the best teams in the world. I think what gets us going is, India, there's a concentration of talent, and we have a mission. We're taking this mission to heart. In 10 years, we want to be, in the top 5 fabulous companies in the world, right? We're taking it up. And this is a mission that motivates everybody who's joining us, and even some of the brightest minds in the country who are young. They're giving up their, jobs in Databricks and Rubrics and joining us, right? So we are on a mission. So what else do you want me to say?
I think that's good. We'll come back to, I think, some of the challenges. I want to, because I know.
Yeah.
Let's give them a big round of applause. I think it's really going after a big moonshot. Preetham, let's go to you next. Maybe talk a little bit about what is C2I trying to do. Maybe again, like give some sense of the team's background, and also, you're only months away from a tape out. So maybe you can talk a little bit about whatever you can share, share with the group.
Sure. Our background is we pretty much came from Texas Instruments in Bangalore. The beauty is we were the ones who actually started power management in TI 20 years ago. So we built it, got it to a point where there's huge revenues, huge technology that got built into the place, did process development, built fabs, did OSATs, did all that learning. And there came a point where we said, what is it exactly we're trying to do and sitting in a corporate company versus big motivation, thank you to Government of India and the ISM, that the question really came what is it that India is trying to do, and why is it that somebody like me who's done 25 years of power cannot contribute to that. That's how it started. And then I think 5-6 of us who came out from TI were pretty much the heart of the group. TI actually very welcomingly let us go, set up the company. We started C2I in 2024. And we were also lucky to get DLI. And the story basically is why power, right? I'll try and put it down as simply as I can. If you look at AI, AI has completely changed the way we build even data centers. Most of you probably know about it. And then what used to be a systems problem, a training model AI for human interface, changed to a completely different way of always on AI, trying to convert data, silicon, power into intelligence at a scale that is unprecedented, right? What does it really translate to? We used to talk about having GPUs on cards, that's what really, now it is GPU clusters and GPU racks, that's the scale of AI, right? How does it translate to power, right? What used to be few hundred watts of GPU and a rack of maybe a few kilowatts today is hundreds of kilowatts. And then which means if I'm putting 10 racks, filling up this kind of a space, we're already talking about a megawatt of power getting into this simple room here, right? And then that's the scale, right? And when you bring in a megawatt of power, by the time it comes from the grid to the actual GPU that he's trying to put together, you already lost 30-40% of the power in distribution, in conversions, and in cooling. So power lost is power not doing something useful, right? Generating tokens, for example, right? So that is really the crux of the problem, right? So when you look at how you really want to solve that problem, that's where C2I is trying to address it at maybe 2 or 3 different levels. I'll break it down to keep it simple. At a systems level, we're trying to see, well, we're getting in 800 volts. You're trying to convert it down to maybe 800 millivolts. So that's 1,000 times of conversion. So how do you really do that? How efficiently can you do that? That's the first problem. Second, you're trying to pump in 2000 amps into a GPU. When you pump in 2000 amps into GPU, it needs space to do that, right? What is all that real estate? Right? That active real estate is lost for something that you could do better for processing and management. That's the second problem. The third is, just think of it, like when you do welding, that actually consumes 40 amperes, folks. Just to get a feel for numbers, we're talking about 2000 amps getting into something like he's trying to build, right? That is a challenge from reliability and robustness. Like, how do you keep it up and make sure that doesn't come down? So these are the three different problems C2I is trying to address. And then we have technology that is able to bring down efficiency by a big percent, get the real estate down by more than 3 times or 4 times, and then increase the life by 2x. That's really what we're trying to do. The first tape out is happening in April. We're actually just a 2-chip solution, and the total solution will be like for a 2000 amps, we'll probably have 32 of these little chips and a big controller sitting, trying to manage all the power for like a Marvel GPU, for example, or a Marvel solution, ASIC, for example, right? So that's really what we're trying to build. And I think if C2I really hits the trifecta on all these 3 vectors that we're talking about, I think that we really would have shown you can build such high complex power solutions to meet the AI demands that we'll see in the future. That's the
and there's a huge synergy between what he's building and what
perfect.
Yeah. First make stuff, then you can sell stuff to each other. First step, you got to make stuff. Okay, let's, Naveen, I'm going to get to you in a second. Shashwat, so I think both Agrani and C2I are building global businesses. For them to win, they have to be globally the best. I think Mindgrove, you're taking a different starting position, which is you're building for India first, and I know eventually over time you'll become global. And actually, Mindgrove was the first semiconductor investment that we made. We actually have 4 investments now. Mindgrove was the first. Second is a company called Incore, that's a co-IP company in RISC-V, and then Agrani. And so Shashwat, maybe talk a little bit about Mindgrove, what you guys do. By the way, they've also done a tape out, and this year he's committed to me he's going to generate some serious revenue, and next year is going to be like a waterfall, right? Tell the group a little bit about what does Mindgrove do, where are you guys in your journey? Also, you have a different background, right? You guys came out of academia, maybe so that you have like a very seasoned team. You have a team that's come out of academia and that provides the color.
So almost everything that we're doing is coming from a different end from both of them.
That's why we put you on the other end of the room too.
Yeah.
Just the panel,
So Mindgrove is a company. We work mostly on the edge and not in the data center. We work on things that, things that you guys are holding in your hands. Cameras, phones, later maybe, I don't know yet. But a lot of things that go into phones, like the chips that control the cameras, the smart locks that let you into your house, the controllers that power the drones and autonomous vehicles that run around our warehouses, all of those kind of things. So what we build are microcontrollers, and moving into microprocessors, that's a technical difference I don't think we need to get into. But what you see here, this chip over here, which I'm pointing to, is the chip that we taped out.
The one in the middle?
The one in the middle over here. That's a high-performance microcontroller, which is meant for secure applications. All the things that you need to touch physically, and you still need to keep your data secure. And we are a very young team. I bring the average age of the team up to about 26, 27. So
Really? How like the rest of the team, how young are they?
they're fresh out.
Wow,
We built this
okay.
chip with a total team of 7 people, of whom I had the maximum experience at that point. So there is that. And what we are doing, like I said, everything is on the other side, right? Young team, small team, growing big. And
Don't grow too big though. Keep it small.
yeah, it's nice to be agile. But like Sir was saying, it's a marathon. It's not sprint. And in a marathon, you're paying more attention to what you're doing and improving yourself rather than keeping your eye out on the competition too much. Oh, of course, you need to keep your eye on who's catching up with you, but it's more about pacing and getting yourself to that point where you're at the peak of the performance that you can achieve. And that's basically what we're doing.
Terrific. So I think hopefully you got a sense now of the spectrum of companies that we have, and I think there are 24 companies that you've supported through DLI. So Adit, I hope we've met the remaining 20. Adit is on our team actually. Yeah, I just want to make sure, like, there are 4, but like then like 20 more now.
We also hope.
Yeah, right. So Naveen, let's move to you now. You lead Marvel in India. I think it'll be helpful for you to talk a little bit about what are you guys doing in India, and maybe for most of the group, maybe if you are not Semiconductor, what is Marvel? What do you do? What all are you doing in India? And why are you guys excited about India? I mean, I'm told that you're continuing to double down in India, so it'd be helpful to start there.
Yeah, so Marvel is a fabulous company, just like many others, and our primary focus is on building the data infrastructure. And when we say data, think about it saying you have to process the data, you have to move the data, you have to store the data, and you have to keep the data secure, right? And that's what we do by building infrastructure that goes either into the data centers or into the enterprise and carrier market segment. What it means is that we make a lot of processors, networking, storage, security, and many of those chips. And the way to look at it is that our revenue he was calling the market caps around 8 billion revenue. A large part comes from the AI data center. And if you get into the data center, there's one which called GPU. That's a massive element. But what's happening is because of the different use cases and the workload, we are seeing a custom processing units, call it XPU, that's coming in for you to optimize your workload and get the best power performance and hence build the economics and scale for the product. But then it's not just the GPU. When you open the cluster or XPU, you have a lot of coprocessors and other elements that goes along with it. And then you have the whole networking that needs to be there to connect the millions of them, right? Starting with the switches that needs to be there, the network, the interconnect, which is both copper as well as electrical. And then you have to do it what we call a scale up, scale out, and scale across. What means it's on the rack, the racks and I would say the data center, and then across the continents. So we build all of those across the world. In India specifically, I think we are a replica of what the global company is. We build the foundational IPs, blocks, flows, methodology, the softwares, and the packaging. And then we have the business and product teams, which actually integrates all of them and ensure that we can put an XPU, the XPU attach, the networking, fabric, interconnects, and all of that.
Got it. Very helpful.
I should point out there's a little bit of a statistical anomaly here. Naveen and I are batchmates from undergrad, so 6 p.m. in a global AI conference on a semicon panel, 2 guys from the same batch.
Oh my God, that is insane. That's great. All you have to do is catch up to 70 billion of market cap next.
You are on track.
Yeah, no, and I mean, I've been very clear since he's
years.
shooting for $1 billion.
10 years.
Yeah, 10 years. No. What are you talking about? Are you kidding me? Okay, let's now move to, I think I want to maybe ask 2 more questions and then we're going to open it up. Please have your questions ready. Let's talk about India's right to win. I mean, as you can see, right, like this is an ecosystem that had 0 semiconductor startups 5 years ago, right? Like what, 2020? There was 0, yes. Right? Today we have 24. We have companies building sort of, chips on the edge all the way through GPUs. What is India's right to win? I know the headline always says 20% of the world's semiconductor designers are based in India. Lots of these global companies are doing cutting edge work. And then obviously when you have great talent in these companies, they spin out and start companies. Exhibit A, Agrani, Exhibit B, C to I, Exhibit C, soon to be Naveen. No, I'm just kidding. No, just joking. I know you have a bunch of your Marvel colleagues here. They'll all like go, whoa, what's going on here? Anyways, but so we got that part, okay? But what else? Like, and maybe even on that part, maybe Naveen, you can start with, to what extent are you doing the really cutting edge work here, right? Talk about that. And then since you guys obviously have capabilities here, you build big centers here, like as you look at India's right to win, not as Marvel, because for Marvel, your capability for the company, but as these other 3 companies, right? Like other than having awesome talent, what else is our right to win?
Yeah, so if I pick 2 examples of what the cutting edge that we are doing and then maybe build on it, right? So many of these building blocks, very high-end processors or the networking, the main foundational building block is an IP called SerDes, right? You need to have this serializer, deserializer for you to be able to push the data around. And it has gone to the insane speed of what we call as 448 gigahertz speed. And that IP is built by, I won't even go to the second hand, right?
Wait, how many people?
Few people in the
world.
Few companies in the world.
Okay, in the world, and how
Yes.
many people within those companies?
Few hundreds.
Wow, not
Yeah,
bad.
yeah.
How many of them are in India?
Quite a lot.
Really? Like how many? Like
VLSI,
50? No, like let's get specific. No, this is important. I mean, it's important for us, Adit. You know,
I mean,
Adit
you
and
have
me is
that.
very
You have
important.
that metrics, like 20% of that.
I know, but 20% is a big number. If you tell me there's 20 of them that matter, okay, we'll go find them.
Yeah.
Okay, so that's interesting. So you're saying meaningful percentage of this really high caliber talent is in India.
It is in India and across. I have one of my colleague as well who is doing it from here as well, right? So there are quite a few people doing this. And that's the building foundational block for any of these chips that we're talking, especially in the data center and AI. And it's equally there in the other side. But we have a lot of those being done from here. Not just the design, but the whole layout, validation, characterization, and all of that. That's one part of it. The second one, I'll twist it, is that, right, we are building the solutions for the AI of the world. But when AI is ready, how do I use it? So that I can turn around and do the chip in 12 months. I think you'll like it. Just like you'll ask these guys, can you use AI to shrink the cycle time?
So what, you just talk about that. What is the impact that AI will have on development cycles in the semiconductor today?
It will. I think all of us are quantifying at this time. Any number I say is more a gut feel than anything else. It's a case of saying, do I reduce the iterations? Do I add value into the chip by using AI? Or by, like, just shrinking the whole cycle by the brute force because we can run things on GPU or do iterations fast and all of that, right? But that's, again, is another very, I would say, strategic angle, that how do we leverage AI for my chip design and the software design and the system design so that I can bring this whole thing faster into the market. And because every year you want to see a new infrastructure coming up by the hyperscalers and everyone else. So those are two building blocks. I would say there are a lot of things you will hear. One topic I will touch, if India has to win, and Sinha sir talked about it, is we are buying a lot of technologies. When we are building these 10 plants, all the technologies is coming from outside. So we have to invest in what we call as the foundational R&D. And that's a project that we are working with Amitesh sir office and many others, is to put up that R&D ecosystem where we have industry-driven research on the next generation device, materials, circuits, architectures, packaging, thermal, power, all of those things, and be ready when these 10 projects and many of these people, they need the next generation IP, next generation, any of this is available from our research ecosystem, which will be primarily industry driven, but may be executed a lot by academia and research labs, and to get us going faster on this journey rather than always relying on buying from outside.
That's a great, and maybe I'm going to come back to you and have you talk about what we're doing in R&D. Maybe now let's go through with each of the three founders. Dimant, we'll start with you. You were about to talk about challenges. Yeah. Right? What could make it easier for you guys to achieve your mission, and what can India do really? And we have Amitesh here.
Yeah. I think if I think about it, Rajan, right? There is talent. I don't think that's a problem.
Can you get the talent that you need in India to build out, tape out a GPU?
Yeah. So, what we are building is deep tech in hardware, deep tech in software, and in some ways manufacturing as well. And I can tell you, like, order of 100 billion transistors, PyTorch to, Compilist, all of that. We are hiring largely in India. I'm not sure if we can build 20 such startups, but 5 with this concentration of talent, definitely end-to-end teams, I think we can. So I was just going to say there's talent, there's capital, there's the whole ecosystem, supply chain and all of that, and then there is go-to-market, right? And just market access. I would say talent is not a problem. I think because for the reasons we're talking about, right? There are so few of these. We have 20% people doing silicon design for 30 years, people doing software, low-level system programming. So that talent is not a problem. Capital, I think, between what folks like Peak are doing and what the government is doing, understanding patient capital better, understanding how the semiconductor cycles work, I think we'll figure it out, right? So, and I also feel like as entrepreneurs, we'll figure it out, right? We will, right? We'll figure it out. I think the third aspect around ecosystem, supply chain, definitely we need help, right? At the end of the day,
and break it down, like maybe break it down. What are the specifics so that I'm sure he knows, but for the broader audience?
Yeah, simple things, right? Like today, the supply chain is monopolized by a small number of big players, right? Whether it is access to wafer starts at a place like TSMC, memory, right? Any chip of the nature we are building requires high performance, high bandwidth memory. There are 3 memory vendors. it's all sold out. Like if you want to go buy memory for this year, it's sold out, right? So
What a great business to be in, huh?
absolutely, and you can see the markups that these guys are getting, right? So it's unbelievable. So I think the point is that access to supply chain is something that gives me sleepless nights. Definitely, I think with the good offices of the government, and I would say, how do we do it? Today we are going to partner with the likes of Marvell or a Broadcom, who will be our conduit to these supply chains. But they have to believe in us because we have to make business sense, and there's an opportunity cost for them to do it. So we have to solve for that. And I think between the government essentially using their good offices, for example, Micron is a big player in this ecosystem. So there should be an allocation from Micron for India, as an example, right? If I am going to build a world-leading product, Micron should allocate HPMs to India, and that can be something that can be arranged, right? So that's one example. Then when it comes to market access, same thing, right? Like I said, I have no concerns about us building, and I'm not just, it's not bravado, right? I'm just saying that in the true sense, give us 3 generations, we will be a world-class product. But it's not just about building world-class products, it's about monopolies and market access and how do you penetrate and so on. That's where we'll have to figure out, right? How, that's where I think, again, the government can come in and, we, just for context, right? We are at 1.2 gigawatts of installed data center base today, going to 8 or 9 gigawatts in 5 to 6 years. A gigawatt is 400,000 to 500,000 GPUs. And if you say each GPU is, $40,000, right? Just 1 gigawatt of GPU deployment is $20 billion. In India, if we say that, we are going to have 4 gigawatts of deployment in the next 4 or 5 years, that's $80 billion. Now, if there is a worthwhile technology team that is building for this market, and we are not asking for favors, right? We are going to be, right up there. How can there be a policy that helps us penetrate this market, right? That's what gives us sleepless. I mean, we will compete at the global level. We are building from India for the global market. We will work with global players. We will do all of that. But it's our technology. It's our markets. There's data sovereignty. I mean, we talked about yesterday, Rahul from Anthropic was talking about second biggest knowledge usage of Anthropic, right? And so when technology is being used so rampantly here, it's only natural that technology that's built here.
So that's good, right? So supply chain and market access. Market access specifically, I mean, in a massively growing Indian market can be created.
And we can be the leaders of global South. Amitesh ji often talks about it, right? It's what we build here. There may be, geopolitics on whether we can sell it to the US or not. We'll figure that out. But we can be the leader of the global South, and that's a big market. So we should just work on it.
Got it. Preetham, anything to add in terms of constraints outside of those 2 topics that Dimant highlighted?
Maybe I'll take a minor detour from the talent portion of it. Right? I think what India has been building as a skill is to know how to do things. I think there are great talent available in semiconductor space. I think for the last few years, at least the top players like Marvell, TI, Renesas now, they're all investing in building technology leaders. Like you need someone who can use that 20% talent pool, put them together, guide them in build something that we wanted to put together. I think that technology leadership is where really India needs to focus on. I think encouraging them within the organizations or outside the organizations through startups like TI or C2I will be the way to go forward. That I think is one dimension. I think second dimension, just to extend on the ecosystem portion of it, I think today, India is at a beautiful cusp of transitioning from build in India to actually make in India, right? I think you can do everything that we are talking about completely tops down, end to end, where true systems down to the last component can be done out of India and should be done out of India, right? I think that technology equity is what India needs to invest in now. And that only comes when you have the right ecosystem partners to go with, right? Today, if you see his $80 billion that he talked about, that there is $2 billion of power right there. Right, so I think there are pieces that you can put together in a much more potent way, analyze the problem, saying, if I'm building a 1 gigawatt equivalent system, a data center for India, for Indian applications, okay, this is how it should break it down to, this is what I really need from an end-to-end system, and then this is the components I'm looking for. Hey, I have all of these in India, now let me go out and get it.
Yeah, and specific goals, right, to what he's saying. Let's say we talk about population scale AI, right? This whole summit is about population scale AI. And in India, there are always inflection points around cost when after that things take off exponentially, right? And the question is, we take goals and say, in India, AI is going to be delivered, services are going to be delivered through voice, most likely, right? And it has to be delivered at, let's say, 5 paise per minute per user. What does that mean? Everything from the model to the infrastructure layer to the compute layer. How do we actually have a blueprint to be able to deliver that is something that we can work together.
Got it.
Build
You want
that
to
system
let's
expertise.
let's just in the interest of time. Anything to add to what they brought up?
I will chime in on the supply chain part of it. Definitely, everything that he said is true, and I'm feeling it a lot more as we go to deployment. But one tack that I would like to take is one really great challenge that we have is also created by the opportunity that we have. We have a huge population, but it's a very disparate
We
population.
can see it today. I mean,
Yeah.
I think they're all here.
Hopefully not all, but we have very disaggregated kind of a population. So gathering volume, it's hard. And again, to your point, great product design is necessary. That's a skill. I don't know how to teach that skill, but great product design is necessary to aggregate that volume to actually be able to serve the entire country, because the needs are so diverse.
All right, cool. So let's maybe I'll have you respond to some of these asks, and then we're going to open it up for a couple of questions. We don't have too much time left. So Amitesh, I think maybe start with R&D, because I think that is a super important point. Maybe talk a little bit about how are you guys thinking about R&D, and then supply chain, as well as market access. Maybe just those three areas, and what are you all doing?
Yeah. So, friends, we all know that technology, sometimes it is available, sometimes it is not available. So whenever we talked about high power computing earlier, it was not available to us, and now we are developing, and now it is available to us also. Similarly, in future, we are doing 28 nanometer to 180 nanometer. When we come down, probably technology will not be available. Though commercially it is available, all companies are setting up elsewhere, but perhaps they will not set up here. So, should we wait for them, or should we develop something? So now R&D, which Government of India is focusing, is all those kind of technologies. Suppose your advanced node is there. You want to attempt 7 nanometer, 5 nanometer, 4 nanometer, 3 nanometer. Then you want to have a display ecosystem. So you want to attempt OLED kind of R&D in India to have, because these technologies are quite guarded. So unless LG and Samsung is not coming to India, it will not come to India. Similarly, you want to transfer data at a very high speed. So whether you want to do in silicon photonics or a similar kind of technology, there are various kind of technologies. So in each of these technologies, which is very critical, whether it is a quantum or any kind of other kind of materials, we will now venture into that area. So this is one thing. Second is that ecosystem is very, very important, that all of them have said. So tape out at TSMC will take a very long time, but getting a memory will get a very long time, because the situation is like that. There are many such ecosystem problems. If they want to do a very critical 2 nanometer or below that also, designing, they need a material of a specific nature. So again, material R&D is also important. So ecosystem takes care of everything. So now they are talking about power. So power dissipation is a very, very important thing. So can you do something on diamond as a substrate, or can you do something to dissipate heat? Because all these solutions will need such kind of material and substrate. So this is the area of ecosystem. More and more will be approved. So we are seeing a very good proposals in different technology, whether it is GaN or on sapphire or silicon carbide in different flavors, and then advanced packaging is again a very, very important thing from today's point of view. So we will approve many such projects, including R&D in material, equipment, and other things. Precision engineering is also very important. So this will fill the ecosystem gap, narrow the timeline, and then the market access is a very, very important thing. So there are two ways to gain market access. Either government is procuring or government is not procuring. Whether government is procuring, we can do many things, because Make in India, there are a lot of provisions are there, and we are going to leverage that. So for all its strategic applications, whether it's a defense for space, and we can define strategic application depending upon our need, our security concerns, our different things. So on those area, we can mandate something, and our startups, our innovators, our product developers can have access. On commercial side, which is not directly covered under Make in India, there are many ways, because we are getting a lot of substandard items, and ultimately consumers are losing on that. So suppose you are having a two-wheeler and your charger is not working. It is just because the standards are not good. So we can impose many such conditions also to see that the credible stuff is coming to the country, and there is a level playing field for our startups. And for that, for providing that level playing field, we are now funding them. We want to be their partner. We want to give them all kind of supports in terms of EDA tools, which is a very first enabler for a startups is EDA tools, which is very costly. And then we will also provide them some incentive. So once they are ready to run, at that point of time, because of sheer scale, because you are not matching to the fabless companies of the world, probably the tape out cost will be high, the marketing cost will be high, all those things are there. To cover up those things also, we will provide certain PLI in terms of a level playing field for the startup. So all these things, I hope it will take care of much of their need, and probably we will see a lot of fabulous company and unicorns coming from semiconductor domain.
Terrific. Well, thank you for that. Okay, let's open it up for a couple of questions. There's a gentleman there in a tie. Are you with Qualcomm?
No, I'm.
No, not you. Yeah, the gentleman with the glasses, with the tie. You don't have a tie on. You haven't realized yet.
Thank you very much, sir.
You too.
I am Aziz Akram from Ministry of Economy and Finance of Uzbekistan. I'm not from Qualcomm. So,
oh man, bummer. I've been trying to meet somebody from Qualcomm. You know, they just did a 2-nanometer chip tape out. I'm trying to find that team. I thought you might be. I was just trying my luck.
Okay.
Go ahead. How are things in Uzbekistan? Yeah, go ahead.
I'm director for Semiconductor Strategic Development within Ministry of Economy and Finance. So I have just a couple of questions. I need your opinion, thoughts. So can you say a few words from your experience from a starting point in semiconductor industry first? If and the second question is, for countries who are not the part of this current leading semiconductor ecosystem, what is the most realistic entry point? And what would you advise? What would you do first if you were advising the government today?
It's a great one for you, Amitesh.
Yeah. So experience-wise, I will say that initially it will be difficult, because a company will not believe you. So, so this journey started from 2022 when the scheme was rolled out. And whenever we were discussing with any global company or even global experts, Indian experts staying outside India, they were not believing this story, and they were all of them were giving lot of knowledge and sharing their experience. So we called in Hindi, it's called Gyan. So a lot of things, but we took it very seriously. We said them, what are the 1 or 2 or 3 or 4 or 5 advices that you want to give us? And they all gave us good advices. We followed them, and then we started seeing that things are happening now. So when the DLI started, there was no startup company. So we saw some companies coming around, and then the manufacturing happened. So no tier 1, tier 2 companies still is there except Micron. So the companies are not believing that actually it can happen in India. But the moment you will start growing, so in 3-4 years journey, now we are seeing that many good companies are trying to come to India, and they are very interested. But still, the tier 1 is missing. So that may come towards the end of Semicon 2.0 or in Semicon 3.0. Every company has to come here. This is my gut feeling, because the market dynamics is like that. So we cannot be avoided. So my suggestions to all global companies who are listening this is an opportunity. And Government of India is also tapering down their incentive. So first movers who have took courage to set up this ecosystem, government has enabled by giving more capex subsidy to them along with the state government. When ISM 2.0 will come, you will see that it is tapering down. And when ISM 3.0 will come, you will see the further tapering down of incentive, because now we are creating an ecosystem. And that ecosystem pulls investment. Many companies today, memory company, they want to produce memory in 1 year time, not 2 years time. That's why they are acquiring ready-made fabs outside. So PSMC, P5 is one example that company wants to manufacture memory because the cost of memory today is very, very high. So that is the ecosystem that is enabling them manufacturing HBM or other kind of memory in a faster way. So that kind of ecosystem we have to create so that companies automatically come irrespective of the incentive or financial support coming from our side. So believe in any kind of policy. Try to implement those policy in a transparent manner and interact with the industry. So today, METI is not working like a government ministry. We are working fully with the industry players, whether it's startups, whether a company like Peak 15 or any manufacturing company or global company like Marvel. So we are interacting with them. Still, we are learning with them, and we'll continue learning till we set up this complete ecosystem to the satisfaction of global companies, tier 1 company, which will compel them to come here.
Terrific. There was a question. No, if you just in the interest of time. No, go ahead. Yeah, now you can go ahead.
Yes. Hi. My name is DJ. I work for a company called Grok, which just got acquired by.
Yeah, we've all heard of it.
Yeah. So,
by the way, Dimant, Grok would be nice. 20 billion, not 10, not 1.
I'd first want to hire him.
Yeah. By the way, yeah. Go ahead. Now, anyway, now you're with NVIDIA, or have they offered out the letters yet or not? Anyway, just kidding. Keep going. Go ahead.
Yeah. So my question is around. So you said right, there are 3 companies which essentially does HBMs, right? Micron, for example, has stopped any of their consumer RAM. So my question is, what is the bottleneck when we think about HBMs? Like, why aren't there more companies doing HBMs other than Hynix, Micron, and Samsung? There should be more, right? It's just concentrated within those 3. So how do we solve for that? What are the bottlenecks? What are the next steps outside of those 3?
Yeah, I'm not a memory expert. Maybe Naveen can chime in as well, right? But I think this is pretty high-tech technology, right? Just think about it. I mean, HBMs, you have stack of 16. It's something that has to fit in a package. When we talk about HBM 4E, in the time frame that we would have products, these are 16 giga transfers, the cooling, the thermals, and DRAM has its own scaling challenges, right? The DRAM cells. So it's pretty high tech, right? Just like, it's hard to have a 2 nanometer fab or a 3 nanometer fab. It takes time, but I think there are green shoots in places like China. They are creating a parallel memory ecosystem. It's something that we have to study to see, what's our priorities. Memory obviously is a bottleneck. The other way to think about it is, should we leapfrog and come up with more innovative ways to not rely on something like a HBM, right? That may be the other.
Great, thank you, Dimant. Naveen, do you want to add anything to that?
No, he's covered. We can take more questions.
Okay, good. Yeah, there's a question here. Let's take these 2, and then I think we're going to have to wrap. Yeah, go ahead. Yeah, give me a mic.
Hi, I am Shashwat. I'm the founder of Grada.ai. My question is to Dimant. So you said that in 3 generations, you'll have the hardware capability that is like state of the art, top of the line. But like AMD as well has the hardware capabilities that are much better than NVIDIA in the AI space. But still they don't succeed as much because of CUDA and their ecosystem. So do you have any plans that to challenge in the software line? And
no, that's a great question, and you're hitting on the core of all our learnings. We build GPUs at Intel. I was at AMD. Software is a challenge. It has to be thought through, and one of our strong focus areas is around software. We are a software first company, and we're kind of inverting and thinking to the ecosystem and how the software ecosystem is fledging and how to leverage it. So that's probably as far I can say today. Right?
Watch the space.
Yeah.
Great question.
Is there an open source thing that?
No, I don't think he's comfortable sharing, but that is the heart of.
Rajan,
you hit it.
While we wait for the next question, from our side, what we say is software-driven co-design. So hardware and software work together, but software is driving the hardware design.
True. Yeah. Let's go ahead.
Yeah. Hi, I'm Ish Bhargav. I'm both from electronics and semiconductors on the product side. Just lucky, I have a suggestion and a comment, actually, both. And when we are talking about GPUs, and C2I, what we really need is systems company to make them successful if you are looking at to go global. So I think that is something which has to be addressed as part of the policy, I think. Because otherwise it cannot happen, because world over we have grown, from assembly to electronics products to chips, we have not gone through that trajectory. We are still at the EMS, and suddenly we have jumped into chips, So that system thing is totally missing in the country.
Yeah, that's a good point.
We need a policy for that, really very quickly. Even for him, it's the same problem. Where it is will use, like he was talking about product designers. That's a very good, I think, problem we have to solve. Because we have been into services, we don't have product people, product managers, that mindset. That's a very big gap to be
absolutely, yeah. And system design is getting a lot more complicated.
I mean, we don't have companies design. We need a policy and a system, to make system. When I say board level, racks, those kind of things.
That's correct.
Otherwise, we will be just doing GPUs. Nobody to sell. We have.
Got it. I think it's a good suggestion. We'll keep going. Good suggestion.
Second
point,
go ahead. Just very quick, just to add, when we are talking again GPU kind of thing, we have to look at lower level of software, and that requires again a policy, either in AI mission or ISM. I don't know. All the way, from the firmware, middleware. We have to go, because today this world is dominated by CUDA. And if you want to get into GPUs, it's a very long thing, very long race, So I think that has to be done parallelly as a part of policy. Otherwise, out of India, going a full solution would be difficult,
Yeah.
We will get.
Go ahead.
Actually, Meti has already noted this point. And we are already working on this kind of system, particularly in HPC and all other full stack and development of softwares across the top layer and bottom layer everywhere. So that exercise is going on. In that process, we are also integrating all kind of startups and all kind of new innovation that is coming. So whenever this will come, it will come as a complete solution. And in the meantime, what the problem you are mentioning, it's a real problem, and we need a lot of product companies. And for that, there should be a conducive environment also. So you will see that progressive government policy will try to address this product development also.
And just to add, HD, I think one important aspect is, like, at least from when you look at C2I, right? The way we are trying to solve the problem is to look at the entire system for the way the power actually is from the point it reaches into the hyperspace or hyperscaler to the GPU, right? That's how we are trying to address it, and then break it down into a piece that becomes a semiconductor problem. That is how we are trying to address. And I think most of these, same for Mindgrove or for Agrani, right? Gen 1, you are actually building a product. Gen 2 and Gen 3, when you are actually trying to get to a leadership position, you have to think systems end to end. I think that is natural when you start to build a technology for a global market and trying to establish a leadership position, right? That is how I think we need to gear up and stop looking at components and start looking at, how do I take this component and address the space in a much wider way. That's how I think it'll grow.
I think his point is that we are missing a family called OEM, ODM system integrators. We'll have to acknowledge and create them as well in the ecosystem.
Yeah, so that exactly is the point where we need to put.
What you need is anchor customers.
Exactly. So I think what we need is
solution gets proven,
Yeah, but here's what I would say, right? I mean, this is all valid. NVIDIA is a US company. There are no, supply chain providers in the US. A lot of the manufacturing gets done in Taiwan. It's still a $5 trillion company, right? Let's start with building what we can, and we'll build the ecosystem, right?
Okay, so, with that, I think you guys should take this offline. I think it's a very fascinating conversation. But thank you, everyone, for joining. I want to first thank Amitesh. Amitesh, thank you to you and the team for the heroic work that you guys are doing. And also, I think to our three founders, it's absolutely wonderful that you guys have moonshot companies that you're trying to build. And Naveen and Marvel, thanks for I think leveraging India to the best, and hopefully we'll be able to find those 5 people at the company that are doing this very special things. All right, with that, guys, thank you very much.
Big thank to Peak 15 also. They have funded 4 startup companies. This is very, very needed. And unless companies, VCs like Peak 15 is there,
Thank you.